Everyone, welcome back to Colossals Mathematics class. Don't forget to subscribe, like and share this video. Alright, in today's class we'll be talking about median. In our previous classes we've been able to talk about the mean, and then we also spoke I spoke about the mean and assumed mean of grouped data. Alright, so in this video now we are addressing the median of group data. Now, what is the formula for median? The formula for median of group data is median median is equals to L plus, then open a bracket, n over 2 minus CF, n over 2 minus CF, then all over F, then close the bracket, then multiply by what? By H. Now that H can also be called C. Now let me explain what each of them means. The L, it is here already. The L is the lower class boundary of the median class. I get something. L is the lower class boundary of the median class. The N is the total frequency. The CF is the cumulative frequency before the median class. The F that is here, this F is called frequency of the median class, and this H is the class size. I explained what class size means in the last video, so if you have not watched that, do well to check out what I explained there. All right, so now let's get into it. Now look at the example we have here. We have an example. The example says the table below shows the mark obtained by 40 students in a mathematics test. So we have 0 to 9, 10 to 19, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. Now this type of data is called a discontinuous data. This is called what? A discontinuous data. Why do we say it is discontinuous? The reason why we say it is discontinuous is because what? Is because we are having, if you look at the interval now, you can see that we have what's it called, 0 to 9, and then the next one is from 10. That's why we call it a discontinuous data. You can see the class interval is discontinuous. This is what we call the class interval. All these 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, they are the one we call the class interval. Now, because this is a discontinuous class interval, that means this data is going to have class boundary. Now let's get into the solution. So your solution is going to be your class interval, which is the same thing as the class mark. So this is class interval. Do you see that now? So after writing your class interval 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. Now what you want to do is to make it look like a continuous data. And to make it continuous, you will introduce what we call the class boundary. Now, how do you do class boundary? You see that we have 0 to 9. So since it is starting from 0, you leave this 0 again. I get what I'm saying, but you will add 0.5 to this upper. This is called the lower class interval, and this 9 is called upper class interval. Do you get that now? Lower class interval and upper class interval. So you will add 0.5 to the upper. You will subtract 0.5 from the lower. I get what I'm saying. You add 0.5 to the upper, subtract 0.5 from the lower. I get what I'm saying now. So this is gonna be 0 to 9.5. Then you subtract 0.5 from 10. That will give you what? 9.5. Are you seeing that now? That will give you 9.5. then add 0.5 to 19. Now that will give you 19.5. Subtract 0.5 from 20, that will give you what? 19.5. to add 0.5 to 29, so this is 29.5. Do you see how they are getting that now? So subtract 0.5, that's 29, add 0.5, that's 39.5. Subtract 0.5, 39.5, add 0.5, 49.5. Subtract this, add this. Do you understand how we got that now? So that is the first major thing. Now you can see that I've been able to make it look like a what? Like a continuous data that I was speaking about. I've made it look like a what? A continuous data. That is the first goal. I get what I'm saying. Now you may be asking yourself, what if I have a continuous data? We'll look at example like that. All right, so now I've been able to make it look like a what? A continuous data. Yeah, you may also be asking, okay, Colossus, what if I have like from the beginning, if it is not 0, what will happen? So let's say you have let's say this is 1 to 0, 1 to 9. I get what I'm saying. If it is 1 to 9, you will subtract 0.5 first, so that will be 0.5. I get what I'm saying. Okay, let me use a bigger number. I don't want to confuse you at all. So let's say the first number is from 8 to, let's say 8 to 10. So your first class interval is going to be what? 7.5 to 10.5. Do you understand that now? So that is the first thing. You will always add 0.5 and subtract what? 0.5. I guess what I'm saying now. Add 0.5, subtract 0.5. Don't forget that. That is how you deal with class boundary. That's how you always get your what? Your class boundary. Is that okay? All right, so now that we've gotten our class boundary, the next thing, we have our frequency. They've given us the frequency already: 4, 5, 6, 12, 8, and then 5. Do you see that now? They've given us that already. So let's get our cumulative frequency. Yeah, cumulative frequency. How do we get cumulative frequency? To get cumulative frequency, what you are going to do is the first number here, which is what? Which is 4. I get what I'm saying. So this is 0 plus 4, and that's how you got this 4 here. All right, now 4 plus 5, that's what gives us 9. Are you seeing that? 9 plus 6, that's what gives us 15. 15 plus 12, that's what gives us 27. 27 plus 8, 35. 35 plus 5, 40. Do you understand that now? That's how to get that. So this is 0 plus 4, then 4 plus 5. This is that 4 plus 5, that's 9. I'm sure you understand the arrow I used then. Then 9 plus 6. 9 plus 6, that's how they got 15, and it goes on and on like that. If you don't understand, please do well to ask questions. All right. Okay, so let me put a ruler back here. All right, so 0 plus 4, that's what gives 4. Then the 4 you have here now plus the next frequency, that's how we got 9. The 9 plus the next frequency, that's how we got 15. 15 plus next frequency, 27. Do you understand that now? 27. 27 plus next frequency, 35. 35 plus next frequency, 40. Now there is one sweet thing about this data. There is one sweet thing about this cumulative frequency and then frequency. Now look at our total frequency. Let's add our total frequency together. 4 plus 5, 9, plus 6, 15, plus 12, 27, plus 8, 35, plus 5, 40. Now if your answer here, which is 40, is not the same with the last number you have here, then there is a what? There is a problem. Then there is a what? There is a problem. Your total frequency must be equal to the last value you have here. Do you understand that now? They must be what? They must be equal. Now that we've been able to get that, so let's come to our data now. Don't forget, the question is that you should find the median. Calculate the median of the distribution. Now, to calculate the median, don't forget I told you that the formula to calculate the median is equal to what? You should already know the formula. L, can you see L plus, then we open a bracket, n over 2 minus CF over F multiply by what? By H. Alright, I don't know why this pen is doing like this morning. Okay, so minus what? Minus CF. Okay, so now the first important thing you must get there, the first important thing you must always get is this, your n over 2. First, you must get your n over 2. And what is your n? N is the total frequency. So you come, what's your total? Your total is what? 40. So you are going to say n over 2 is equal to what? 40 divided by what? By 2. And that will give us what? 20. Do you understand that now? So that's 20. Now, you've gotten 20. You will now come back to your cumulative frequency. You can see I wrote it there, that we find the class interval where the median lies with the aid of cumulative frequency. So now you come here. Can I see 20 here? No. Can I get 20 here? No. Can I get 20 here? No. Can I get 20 here? Yes. So this is my median class. Do you understand that now? This is what we call the median class. Alright, so that's our median class. I'm sure you understand what I did. After you do n divided by 2, you get an answer. That answer you get, you trace it back to your what? To your table under your cumulative frequency, where you can find that value. You can say I can't see 20 in 4, I can't see it in 9, I can't see it in 15, but I can see it in what? In 27. So that means 27 is our what? Is our median class. Is our what? Our median class. So after doing that, you can now start writing out your parameters. So let's write out our parameters. What will be our L? Our L, which is the lower, we said L is the lower class boundary of the median class. So trace it, 27. What's the lower? 29.5. Can you see? So that's 29.5. Do you see that now? 29.5. Now you cannot go and use 30. You don't use 30. All right, don't use 30 because this is a discontinuous data. I get what I'm saying now. It is a discontinuous data, so you cannot use 30. You have to use the what? The class boundary. I get what I'm saying now, because that's how we made it to be a continuous data. So our lower class is 29.5. Now we need CF. What do we say CF is? CF is the cumulative frequency before the median class. Cumulative frequency before. Now look at it. Your median class is what? Is 27. So the cumulative frequency before 27 is what? Is 15. Can you see that now? Cumulative frequency before 27 is what? Is 15. So that means your CF is what? Let me change this again. So your CF here is what? Is 15. Can you see how I'm taking it step by step? Then your H, okay, before the H, let's talk about the F. The F. So this is this. So your F, what do we say F is? F is the what? The frequency of the median. Frequency of the median. So what's the frequency of our median? The frequency of our median is what? Is 12. Can you see that? 12. Do you see that now? So 12. Now the class size H. The class size what? H. How do you get your class size? Just subtract this one. That's 39.5 minus 29.5. That will give you what? 10. Do you see that now? So that is your what? Your class size, and it is consistent for everything. I get what I'm saying. Your class size will be what? Will be consistent for what? For everything. Is that okay? All right. So now let's apply it to the formula. Let's apply it to the formula. Let me clean this part so that I can write here. So now that will be median equal to, what's your L now? Your L is what? Is 29.5. Isn't that plus, then you open a bracket, your n over 2, you've gotten your n over 2, which is what? 20. So that's 20. You can still write 40 over 2 if you want that. That's 20 minus the CF, that's what? 15. So that's 15 over the F frequency, that's 12. Then close the bracket, multiply by what? By 10. Do you see that now? Multiply by 10. So this is gonna give us what? So this is gonna give us 29.5. So 29.5 plus 20 minus 15, that's 5 over 12, multiply by what? By 10. Are you seeing that now? So that will now give us, what? 29.5 plus 5 divided by 12 is 0.147. Confirm that on your calculator, then multiply by what? By 10. Do you see that now? So that will give us 29.5 plus, multiply this together, that will give you what? 4.17, right? 4.17. And then if you add it together with 29 points, this, that will give you what? 33.67. So that is our what? Our median. Do you understand that now? So this is our median mark. Do you understand that now? So that is our what? Our median mark. Any question? If you have questions, feel free to ask in the comment section. Ask the authority and I can have a section with you. All right. So if there are no questions, that is all on this first example. Do you understand that now? So I'm going to do another example on, okay, I think we should see another example on this first before we proceed. All right, let's try to see another example so that you can have a proper understanding of what I am trying to talk about. Is that okay? So let's see another example, maybe an example on the continuous data. All right, so let's clean what we have here. So that we can go into another example. All right, don't forget to watch this video in a very calm state of mind, so that you can have a proper understanding of what I'm trying to explain there. Is that okay? All right, so I'm going to look at another example now. All right, okay. So I'm just trying to clean this to avoid any form of confusion. All right, okay. So now that we have been able to clean this off, let's look at a new example. All right, why is my example not loading now? Okay, All right, so sorry about that. So let's say we want to find, let's use the same question, like, but now with different interval, with a different interval. So let's say we have I'm coming, trying to check out the example. All right. Whoa. Okay, so I've seen that now. All right. So you can try this as a class exercise. Try this as class exercise. We have find the median mark of 40 students, also 40 students. So we have 10 to 19. Let me just try to edit this so that I would not have to write a new thing. Let's edit these parts. All right, let's edit these parts. You can try this as a class exercise. Let me increase this. Okay. All right, sorry about all this. So I just want you to have a proper understanding of what I am talking about. Is that okay? So we have something, and then this. All right. Okay, so here we have 10 to 19. You can try this, 10 to 19. Then we have 20 to 29. So try this as class exercise. Then we have 30 to 39. Then we have 40 to 49. And then we have 50 to 59. Okay, so here we have 5. Here we have 8. Here we have 12. Here we have 10. And then here we have 5. So you can try this. All right, the answer you will have, your median, the answer you will have as your final answer, your final answer for your median is going to be 35.33. 35.33. So try that and then let me know if you get the same answer in the comment section. All right, so that is on discontinuous data. All right, so you can try that out. So now let's look at, okay, I think I'll just stop here. I will look at the next example, which is on continuous data, in the next video. All right, so thank you very much for watching and do have a great day. Bye.